Hi. So last time we were talking about, I think we were talking about conservation of momentum. क्या बात कर रहे थे? Last question क्या था जो हमने discuss किया था? What was the last question? Hello, can you hear me? Can everyone hear me? अच्छा केवल मोमेंटम के स्टेप्स लिख रहे थे ना केवल मोमेंटम के स्टेप्स लिख रहे थे राइट ओके so we are going to we are going to utilize those steps now and I will give you, we will be discussing a series of questions where, so what you have to be aware about is that the law of conservation of momentum is a tool, and it is a tool which is used when you have a system which is composed of multiple objects or more than one objects, and further you find that on this system along a particular axis, the force is zero. Then along that particular axis, the momentum of the system must remain constant. Whether the chapter is electrostatics, whether it is magnetism, whether it is mechanics, whether it is modern physics, even, you will find that the law of conservation of momentum is ubiquitous. It is everywhere. The actual application of law of conservation of momentum, as I hope that I have said it before, would be extremely easy. It would be just like what you have done in class 9th or 10th if you have studied momentum over there. It is simply going to be m1 v1 plus m2 v2 is equal to m1 v1 final plus m2 v2 final. It is going to be very, very simple. The law of conservation of momentum is generally applied in conjunction with something else. So it is a very rare thing that you will find that only law of conservation of momentum is helping you solve the question. There are a series of questions where only the law of conservation of momentum will give you the answer. So when you start doing HCV, you will find that they have given at least 20, 30 questions where just the simple application of law of conservation of momentum gives us the answer. But generally, the law of conservation of momentum is applied in conjunction with other concepts like work energy theorem, like motion in one dimension or two dimensions, projectile motion. So I am going to discuss first a series of questions where the answer will be given only by the law of conservation of momentum. Okay. So first we'll tackle that, and once we are good, once we are comfortable at the application of law of conservation of momentum, then we'll move on to questions where we have to apply uh, some other thing apart from the law of conservation of momentum. Okay. So the first question is extremely simple. very simple question. Okay? Please दिया हुआ है देखो. हाँ बिल्कुल सही. Yes. Yes, absolutely right. हाँ बिल्कुल सही है. बिल्कुल सही. Yeah. So, if I were to choose this as my system, okay, then in this system there are two objects, the man and the cart. And because the rails are frictionless, that means that summation of forces along x-axis must be equal to 0. This is given to us. If the summation of forces along the x-axis is equal to 0, this means that the momentum of the system along the x-axis must remain conserved. So the initial momentum must be equal to final momentum along x-axis. So to calculate the initial momentum, all I do is I write down the initial momentum of the cart, initial momentum of the man, plus initial momentum of the cart. 0 plus 0, right? Because both are given as stationary. Final momentum of man plus the final momentum of cart. This will be equal to m into v naught, that is the momentum of man, plus momentum of cart is capital M into v, where v is the unknown velocity. Since fx is 0, initial momentum must be equal to final momentum. This is initial momentum, this is final momentum. So we will get mv naught plus capital MV is equal to 0. V is equal to minus mv naught by capital M. Minus sign tells me that the direction of v, which is the velocity of the cart, will be opposite to the direction of v naught, which is the velocity of the man. या सबको समझ में? This, ये सबको समझ? Anybody not understanding this? Please tell me. Anybody not understanding this? Please tell me. Any doubt here? Because this will be how you will apply conservation of linear momentum across all topics. This would be the complexity of conservation of momentum if required in a question. This is the this will be the staple. This will be the normal conservation of momentum that will come in front of you in a question. where of course other things will also be involved. It won't only be the conservation law of momentum, but it will be the question will be asking you, or the question will be requiring the application of some other law as well. But if that question requires the application of conservation of momentum, then this would be the sort of complexity that you would be dealing with. Okay? So I hope that this is clear to everyone. If it is not, please tell me now. I will repeat what I have said. Please tell me if it is not clear. Okay. So since nobody is saying, I'll assume that it is clear to everyone. And now we move on to questions which have complexity, but only involve the application of law of conservation of momentum. So the next question is, repeat the previous question. If V naught is velocity of jump of person with respect to the car. Now, generally, when you jump off a train, okay, when you jump off a train, you are actually jumping with respect to the train. Whatever velocity you have, it will be with respect to the train. So, for example, uh, and this is highly unadvisable. So, if you want to uh, get off a moving train, right, the train has not stopped as yet, but you are, for some apparent reason, in a big hurry, so that the hurry is so big that you are willing to take a risk on your life. So if you are going to jump off a moving train, then I hope that you will realize that simply jumping off a moving train is a very dangerous activity. आप लोकल ट्रेन के बिल्कुल दरवाजे पे खड़े हो, स्टेशन आया और आपने बोला स्टेशन आ गया और आप चल पड़े, that will result in grievous grievous injuries. So to successfully get off a moving train, uh, थोड़ा आगे जंप करना नहीं भैया, बात आगे नहीं जंप करना होता है. To successfully jump off a moving train, what you need to do is uh, you need to run. Exactly, आलोक. हाँ, किया हुआ है ना, मत करना भाई, ये सब नहीं करना चाहिए. You need to run. So what you need to do, just like you catch a moving train, yes, वो भी नहीं करना चाहिए. So what you need to do is that you need to match your speed with that of the train with respect to the train. आप ट्रेन पे खड़े हो, वेरी गुड विश्वजीत, यस. आप ट्रेन पे खड़े हुए हो और आपने, मन बहुत करता है ना रजत तेरा जंप करने का, हाँ? नहीं करना चाहिए भाई. So you are standing on the train and the platform is moving, right? So, so what you need to do to successfully get off the train is that when you get off the train, you don't let go of the train. Okay? You don't let go of the train. You start running on the platform. You let go of the train when your velocity with respect to the train, almost is something. So केवल अगर कूद गए तो आपकी वेलोसिटी विद रिस्पेक्ट टू द ट्रेन जीरो रहेगी, तो फिर लोचा हो जाएगा. थोड़ा सा मोशन होना चाहिए ताकि वेलोसिटी विद रिस्पेक्ट टू द ट्रेन कुछ रहे. So here, when the man jumps off, the velocity of the man v naught is measured with respect to the train. The guy is saying that, look, I am jumping off the train with a velocity v naught. In that case, what will be the velocity of the cart? Cart is initially at rest. Yes. Very good, Zoel. Yes. यश तूने पिछला क्वेश्चन ही नहीं लिखा ना. Radhika, in the answer of V cart, I want you to find the velocity of the cart, right? So in the answer of V cart, you cannot have V cart. So if I ask you your name, you're not going to say, my name is whatever my name is. That is not correct. हाँ बिल्कुल, जिन लोगों ने किया है वो सही आंसर है, एक्सेप्ट जो वी कार्ट वाला जो वो नहीं आना चाहिए. हाँ बिल्कुल सही पार्थ, बिल्कुल सही सोनल ने बिल्कुल सही किया था. जिन लोगों ने कर लिया है, जिन लोगों ने कर लिया है, next question is that there are two men, two persons, A and B, standing on either side, standing on the same side of the cart, and one jumps after the other. Then what is the final velocity of the cart? Those of you who have not done this question, please remember what I told you in the last class. The most important thing is to have the same frame of reference. Next question, values are the same. Values, same diagram, same everything, values are same. But एक आदमी की जगह दो आदमी है, and they sort of same. So here, what is going to happen is that, sorry, A is going to jump with a velocity v naught, but this velocity is with respect to the kite. So I will go through the whole thing once again. This is the system. The system consists of the man and the cart. So the initial momentum must be initial momentum of the man plus initial momentum of the cart, which is equal to 0 plus 0. The final momentum must be mass of man into velocity of man plus mass of cart into velocity of cart. So now here is the catch. Catch is that this velocity is measured with respect to the ground. So this velocity must also be measured with respect to the ground. Okay, so since this velocity is given as v naught, what I will say with respect to the cart, I will simply invoke the formula that we learned when we were doing relative motion. So velocity of the man with respect to the cart is equal to v naught. This is what is given to us. Okay. So velocity of man with respect to cart means velocity. Let me write it. Velocity of man with respect to cart is equal to velocity of man minus velocity of cart. Now the two velocities on the right hand side are velocities with respect to ground, and the velocity on the left hand side is the relative velocity. So V man with respect to cart is already given to us. V man we wish to find out. Minus V cart is V. This is already we have assumed. So this means that velocity of man with respect to the ground must be equal to V naught plus V. And that is what I will write here, V naught plus V. So 0 initial momentum is equal to final momentum, mv naught plus m plus mv. This tells me that v is equal to minus mv naught by m plus m. The key thing here is that I have measured the velocity of the man and the cart with respect to the ground. Now, the common doubt, okay, the common doubt that I have seen that happens here is that the V naught velocity से जो man कूदा उसके बाद कार्ट की velocity became V. So how is it that the velocity of the man with respect to the ground is V naught plus V? So this is a false assumption. This is a false assumption because of the fact that this is not going to be the sequence of events. It is not going to happen that the man jumps and after the jump, the velocity of the cart becomes V. No, this is not what will happen. So the velocity of the man with respect to the cart is given as V naught. This means an initial velocity of the man is 0. This means that on the cart itself, this means that on the cart itself, okay, on the cart itself, uh, the uh, when the man starts to run, when the man starts to increase his velocity from 0 to V naught with respect to the cart, okay, what is going to happen is that the cart is also going to change its velocity, right? Remember what I told you in the last class. Let me just write it down here. So there is a sequence of events happening here. So this is the axis of time. Nahi, Zoeb, galat answer. So what is going to happen is that first man का velocity zero है, cart का velocity zero. Okay. Man का velocity starts increasing, cart का velocity starts increasing in the opposite direction. Okay. And then the event occurs. This is the event that we want to talk about. So the event is that the velocity of the man has become v naught with respect to the cart, and velocity of the cart has become v. Right? The event happens, the jump happens, और उसके बाद से forever cart की velocity v रहेगी और man की velocity v naught रहेगी with respect to the cart. So what we are doing basically is we are saying that look, the momentum in this situation and the momentum in this situation, or this situation, either will be same. But the problem is that the velocity of the man has been measured with respect to the ground. You just need to convert that velocity to velocity with respect to the ground. That's it. So remember the two things that you have to really recognize. One is the system that you are working with. The second is the event before and after which you will conserve momentum. Right. Next question. There are two people now, A and B. Both of them have mass M. Cart has mass M. So A jumps with always nahi hai, only when the force along that particular axis is zero, external force. A jumps with V naught with respect to cart. Then B jumps with velocity V naught with respect to cart. Find the final velocity of the cart. बाकी सब सेम है प्रीवियस क्वेश्चंस से. फ्रिक्शनलेस रेल्स हैं, इनिशियल वेलोसिटी जीरो है, बाकी सब सेम. हाँ बिल्कुल बिल्कुल जोएब, बिल्कुल सही. यहाँ पे दो इवेंट्स होंगे. First event is that A jumps off. Second event is that B jumps off. And you also have to decide whether in those two events, the system that you are choosing, whether it remains the same or not. हाँ बिल्कुल सही. सेकेंड इवेंट में इनिशियल मोमेंटम जीरो नहीं होएगा. सेकेंड इवेंट में इनिशियल मोमेंटम 0 नहीं होएगा। लग तो रहा है पावरफुल है, उतना ही लंबा है आंसर। हाँ, पहला जो जंप होएगा उसका आंसर तो ऑलमोस्ट सेम आने वाला है ना, जो बिल्कुल बिल्कुल। हाँ, पहले पार्ट में वेलोसिटी आएगी, वही दूसरे पार्ट में वो रहेगा। नहीं बाबे, कुछ गड़बड़ लग रहा है। जीरो तो हो नहीं सकता है ना, तो पॉसिबल नहीं है। पहले इवेंट 1 का निकालिए फाइनल वाला, सो यू हैव टू रियली लर्न सेपरेशन। ए जंप करने के बाद भी जंप करेगा। हाँ, नहीं होगा ना जीरो, मैं कहाँ बोल रहा हूँ जीरो। नहीं भाई, थोड़ा सा गलत ये तो अगले अगले क्वेश्चन का आंसर टाइप लग रहा है। नहीं नहीं नहीं, रुको, मैं करता हूँ, देखो, everybody please pay attention, see how I am going to do this। हाँ जोए, देखो जो मैं कर रहा हूँ, then compare your answer। So I choose the system as first choice of system is two men plus card. Initial momentum will be initial momentum of man plus initial momentum of man plus initial momentum of card, which is equal to 0 plus 0 plus 0, 0. Final momentum will be the final momentum of man A plus the final momentum of man B plus the final momentum of card, which will be equal to mass of man into velocity of man with respect to the card plus mass of man, sorry, with respect to the ground, not with respect to the card, plus mass of man into velocity of man. Remember, B has not jumped, therefore B is on the cart, therefore B's velocity is the same as the velocity of the cart, capital M into V. So if I equate this, I'm going to get 0 is equal to mv naught plus 2m plus m into v. So v is equal to minus mv naught by 2m plus m, which is the exact same answer that we had in the second question. Okay, so the first choice is over, first event is over, and this is the maths of the first event. So this is for event 1. For event 2, for event 2, mv naught plus mv plus mv plus capital mv. mv plus mv is equal to 2mv. आया समझ में जोएब? आई मीन एक और mv, अरे जो मास जो बंदा वहां पे रह गया है उसकी क्या वेलोसिटी हो जाएगी? b की क्या वेलोसिटी हो जाएगी आफ्टर ए जंप्स? ये इसका मोमेंटम है, ये इसका मोमेंटम है, ये इसका मोमेंटम। सेकंड चॉइस ऑफ सिस्टम is man B plus start. The initial momentum must be initial momentum of B plus initial momentum of start. This must be equal to m into v plus capital M into v, जहाँ पे ये जो मैंने v लिखा है, ये जो मैंने v लिखा है, ये वाला v, अभी मैं सब्स्टिट्यूट नहीं कर रहा हूँ, बट ये फाइनल वेलोसिटी थी फर्स्ट इवेंट के बाद, तो ये सेकेंड इवेंट के लिए इनिशियल वेलोसिटी होनी चाहिए. इसके बाद से फाइनल मोमेंटम will be momentum of B plus momentum of cart, which will be equal to mass of man into velocity of man plus mass of cart into velocity of cart. अब जब सेकेंड मैन जंप कर गया तो कार्ट की वेलोसिटी अब v से चेंज हो जाएगी. Let's say it becomes v dash. So this will be v naught plus v dash. Why will it be v naught plus v dash? Remember that velocity of the man with respect to the cart is given as v naught. This means that v naught is equal to velocity of man minus velocity of cart. This means velocity of man is equal to v naught plus velocity of cart. In the first case, velocity of cart was v, therefore I had a v here. In the first case, the final velocity of the cart was v, therefore I had a v here. In the second case, after the second person jumps, velocity of the cart has changed. It has become v dash. So I have a v dash here. Because remember that this velocity v naught is with respect to the cart at that time. Okay. So there should be no confusion here. This is the final velocity of the cart. This is the velocity of the man with respect to the cart. So velocity of the man with respect to the ground must be v naught plus v dash, v naught plus v cart. So I'm going to change the slide now. यहाँ पे जगह खत्म हो गई है. I'm going to change the slide. Please take a screenshot. So we have m plus m v dash plus mv naught is equal to mv plus mv, which I can write as m plus m into v. मैंने उल्टा लिख दिया है, but I hope this should not have any problem. So this is the final momentum. This is the initial momentum. Okay, so this means that v dash is equal to minus mv naught upon m plus m plus v. ये क्या किया मैंने? ये मैंने mv naught को इधर कर दिया तो माइनस mv naught हो गया, और m प्लस m से दोनों साइड डिवाइड कर दिया तो m प्लस m यहाँ कैंसिल हो गया और mv naught के नीचे v dash is equal to minus mv naught upon m plus v, और v की वैल्यू हम ऑलरेडी निकाल चुके हैं, ये रही v की वैल्यू. So I'll just put the v की वैल्यू over here, minus mv naught upon 2m plus v. Right? So this is the answer. अब आप इसको कैसे भी वो कर लीजिए, सिंप्लीफाई कर लीजिए, that's up to you, but this is the answer. Any point which is not understood, please ask me now. Okay, next question. नहीं बेटा, third choice नहीं possible है. So the question being asked is that if third choice of system is possible, and the answer is no, because there are only two events. For every event, you need to choose your system, because for an event, you are going to conserve momentum. So in this case, event one was person A jumping off the cart. So the system that I chose, the system that I had to choose, was the cart and two people on it. Now, after person A has jumped off, okay, now I don't need to consider that guy. So I consider only cart and B, person B. Can you also consider person A? हाँ, जितने इवेंट उतने चॉइस उतनी बार सिस्टम की चॉइस. Can you also consider person A in the system in the second event? Yes, you can, but it would be like, it would just complicate things, and the momentum of person A would play no role in the final calculation, in the final answer. Repeat the previous question. A and B are on opposite sides of card. So first A will jump, then B will jump. नहीं, जीरो आंसर नहीं. अगर दोनों एक साथ जंप करेंगे तब जीरो आंसर. But the question is saying specifically that first A jumps, then B jumps. So this is a question which is same, exactly the same as the last question, except for one thing. What is that one thing? You don't even need to do this question from the beginning. What is that one thing which has changed, and how do you incorporate it exactly? How do you incorporate it? बिल्कुल सही विशु जी. How do you incorporate it in the बिल्कुल सही राधिका, yes. So how do you incorporate it into the second event? हाँ विजय बिल्कुल सही. Do that. तो जो फर्स्ट इवेंट होएगा वो ये जो रेड में बनाया हुआ है मैंने बिल्कुल सेम है. कोई चेंज ही नहीं आएगा. कोई चेंज नहीं आएगा. सेम. The change will come in the second line. Change will come in the second choice of system during the second event. Second choice of system भी सेम रहेगा. लेकिन ये जो PF लिखा है मैंने यहाँ पे बस इधर चेंज आना चाहिए, क्योंकि अब वो V0 से नहीं कूदा है, माइनस V0 से कूदा. All you need to do is put a minus here. That will give you the answer. Please tell me the answer. Same as the previous. Second event, the initial momentum will be this, will be equal to बस यहाँ पे क्या चेंज आएगा, माइनस V0 प्लस V डैश. So V dash will be equal to MV0 by M plus N minus MV0 नहीं सॉरी माइनस नहीं आएगा ना, प्लस क्या मैंने कुछ गड़बड़ कर दिया. क्या गड़बड़ किया. नहीं नहीं, अच्छा अच्छा, वो हो, मैंने समझ में आ गया मुझे। तो this will be v dash is equal to mv naught by m plus n minus v naught by m plus n। हाँ ठीक है। I will stop here। आज मैं ज़्यादा ज़्यादा नहीं पढ़ा पाऊँगा। In the next class, I will show you the application of conservation of momentum with other things। सेकेंड इवेंट में जो मैन जंप कर रहा है उसका नहीं समझ में आ रहा है। ओके, ये वाला क्वेश्चन क्लियर है ना? ये वाला क्वेश्चन तो जोहेब, ये वाला क्वेश्चन क्लियर है? पीएफ में केवल ये चीज नहीं समझ में आ रही है, ये ये वाली चीज समझ में आ रही है ना? ओके, अब देखो, यहाँ पे मैंने कुछ समझाया। मैंने बोला कि जब इनिशियल पिक्चर में मैन की वेलोसिटी 0 है, कार्ट की वेलोसिटी 0 है। अब मैन अपनी वेलोसिटी चेंज करना शुरू करता है तो कार्ट की भी वेलोसिटी चेंज होती है, और जब मैन की वेलोसिटी फाइनली v नॉट हो जाती है विद रिस्पेक्ट टू द कार्ट, तो कार्ट की वेलोसिटी v हो जाती है, राइट? ठीक है ना? अब जो दूसरी सिचुएशन है उसमें क्या हो रहा है कि मैन की वेलोसिटी v है, कार्ट की वेलोसिटी v। अब मैन अपनी वेलोसिटी चेंज करना शुरू करता है तो कार्ट की वेलोसिटी भी चेंज होना शुरू होती है। फाइनली मैन की वेलोसिटी v नॉट हो जाती है रिस्पेक्ट टू द कार्ट, और कार्ट की वेलोसिटी कुछ v डैश हो जाती है विच इज द फाइनल वेलोसिटी ऑफ द कार्ट। दोनों की इनिशियली वेलोसिटी v थी, लेकिन जैसे ही मैन ने अपनी वेलोसिटी चेंज करना शुरू किया, कार्ट ने भी अपनी वेलोसिटी चेंज करनी शुरू की। जब तक मैन की वेलोसिटी विद रिस्पेक्ट टू द कार्ट v नॉट हुई, क्योंकि अभी तो रिलेटिव वेलोसिटी मैन की 0 है ना विद रिस्पेक्ट टू द कार्ट, जब मैन की वेलोसिटी v नॉट हुई विद रिस्पेक्ट टू द कार्ट, तब तक कार्ट की वेलोसिटी v डैश हो चुकी। Therefore, velocity of the man with respect to the ground is equal to velocity of the man with respect to the cart plus velocity of the cart, which comes out to be v naught plus v dash. In the second question, it comes out to be, in the last question, it comes out to be minus v naught plus v dash. ठीक है? चलो ठीक है, ओके गाइस, आई विल सी यू इन द नेक्स्ट क्लास. नेक्स्ट क्लास में इसको और आगे बढ़ाते हैं. अभी के लिए आप HCB शुरू कर सकते हैं. यू कैन गो फ्रॉम क्वेश्चन नंबर 1 तो आई थिंक क्वेश्चन नंबर 40. आई थिंक यू कैन गो वेरी इजीली. कोई इशू नहीं आना चाहिए. कोलिजन्स को छोड़ के आपको प्रॉब्लम नहीं आनी चाहिए. ठीक है? नेक्स्ट क्लास में वी विल 40 तक करो. जहाँ पे कोलिजन है उसको छोड़ देना बस. नेक्स्ट क्लास में विल कंटिन्यू विद कंजर्वेशन ऑफ मोमेंटम. कंजर्वेशन ऑफ मोमेंटम विथ अदर. हाँ, तो कोलिजन वाले मत करना ना भाई पार्ट. मेरे भाई, कोलिजन इज द मेन पार्ट ऑफ दिस चैप्टर ना. विल डू इट इन द नेक्स्ट क्लास. इसके बाद तो कोई क्लास नहीं है ना. मैं मीटिंग एंड कर दूं या अभी अभी और क्लास है इसके? ओके, चलो ठीक है भाई. ओके गाइस, आई विल सी यू इन द नेक्स्ट क्लास. बाय बाय.